In this video we will have a look at different raycasting options. Now this output is from point rendering, and let's have a look at raycasting. So when you click raycasting, you'll get a dialog saying select the level of subsampling. Now this is given in order to because this is volume raycasting, it will be slower. So in order to maintain the interactivity, you are given this option to say select lower subsampling level so that your rendering is interactive. So let's select one, which is take all the voxels. Now this is the isosurface rendering. So this is isosurface rendering, and this rendering is basically first ray hit is basically rendered. You can use clipping plane, so C is for clipping plane, and you can see the solid interior. And delete to remove the clipping plane. Now in volume raycasting, you can change your transfer function, and you would straight away see the effect of that transfer function on your rendered output, which is not the case with point rendering, because in point rendering the point data structure is generated on the CPU side and then transferred to the GPU side. And if you change the transfer function, this data structure is not changed, and that's why you have to click point rendering again to update that structure on the GPU side. In the case of volume rendering, the data is uploaded onto the GPU texture memory, and whenever you change the transfer function, it is just re-rendered. So the same data is accessed, which is not the case with the point rendering mode. So in raycasting mode, the data is uploaded onto the texture memory, and changing the transfer function will change the rendering. And that's why in raycasting mode you are given an option of selecting the subsampling level at the start, so that your data you can fit that data onto your texture memory and maintain the interactivity of your rendering. So this is isosurface rendering mode. So isosurface rendering mode is just take the first hit and render that as an opaque object. Second one is raycasting. So it will take the color of the transfer function and as well as the opacity of the transfer function. So if you change the opacity, then you can see the effect of that changing opacity and changing color on your output here. Now these two are painted, they are tagged, so that's why they are colored differently. So this is like your normal volume rendering. And the third is X-ray. So with X-ray, what the algorithm does is it just basically looks at the attenuation of the incident intensity. So it acts much more like as an X-ray, except that instead of just black and white, you can also have color. So this is the color that we have, and it is the opacity that determines the attenuation or the absorption, really. But it is more additive. So this is volume raycasting. Volume raycasting option. Again, with like point rendering, we can also change the bounding box. So let me just go back to isosurface here, and let me just show the box and then change the box. Now when I change the box, we are not reloading the data. So for example, if you have loaded your data using the subsampling, say subsampling level 2 or level 4, whatever, let me just load that again. So let me load with subsampling level 3. Now when I change the box, I'm not changing the data on the GPU side, so you still have the data with the original subsampling level. As you can see, the image quality, or basically the data quality, is not good because we are selecting a higher subsampling level. You can use the box and now select raycasting again, and you can change the subsampling level here. So this is a way of drilling down into your data. So if you want to look at the whole data set, you can select a higher subsampling level in order to maintain the interactivity. And as you drill down into your data, you can reduce your subsampling level by just clicking again on raycasting, and this will load the high resolution data for that particular selected region. Now if I change the box size, what you will see is only that the part that we had uploaded, only this part that was uploaded, and not the entire box, because there is no data there. If you want to have the data in here on the outside of the selected box, this is the currently selected currently loaded region onto the GPU, whereas this is the currently selected box. So we can press raycasting again and then select the appropriate subsampling level. Now in this case, we can feed the data into the GPU memory and it is interactive enough, so we can select subsampling level 1. But for bigger data sets, you might have to select higher subsampling level. So this is raycasting. In next few videos, I'll show the near neighbor scraping, remove layers, and so on. Sketchpad. Also for raycasting, when you drag, this is the step size that is used, and when you release the mouse button, then this is the step size that is used. So if I select that, I'm changing the drag. You can see the change in the image quality. So still quality step size is always less than the drag quality step size, same as the renderer, Drishti renderer.